So today I'm going to be demonstrating and walking you through the physical and chemical weathering lab. So to start, we're going to start with just section 1. So I'll take you through it. We are going to be on the Chips Ahoy versus wafers. All right, so I'm going to read this introduction to you. Read along. Introduction. Streams, rivers, and waves can be very powerful and destructive. If you have ever been to the beach, you have probably felt the strength a wave carries. A fast-moving stream can be deadly and can carry large rocks downstream in suspension. So suspension means not floating, not sinking, but being carried with the water. This movement of water in streams, oceans, and rivers causes rocks to collide with one another. When they collide, they tend to physically weather into smaller, smoother, and rounder pieces. So we call this process abrasion. It says this process is called abrasion. Some rocks are more resistant to abrasion than others. This varying resistance to breaking is due to a rock's composition. Okay? So from there, you should be able to answer define physical weathering and abrasion. Hardness is an object's resistance to abrasion, and suspension is when a rock is being carried through water or through air, or when something is being carried through water or through air. So I want you to make a hypothesis. We've got 2 cookies here. We've got a chocolate chip cookie and we've got a wafer. What I want you to make a prediction about is not necessarily about the cookies, but about rocks and streams. But the cookies, we can kind of help ourselves think about. So, what effect does hardness of a rock have on the rate of abrasion? So the question kind of is like, do you think that a hard or a soft rock would abrade less, or a hard or a soft rock would abrade more? So that's where you need to make a hypothesis. And how does the duration or length of time affect the amount a rock is weathered? So do you think a rock is weathered more if it spends a little time in a stream, or do you think a rock is weathered more if it spends a lot of time in a stream? Okay, so now we can get into the lab. So you should have this front completely finished. If you haven't, you should go in and completely finish this. Next, we're going to the data table. So what I'm going to be doing is I am going to be having you draw the shapes of Chips Ahoy's and the wafers before and after and while we test them. And I'm also going to be measuring the mass using a balance. I'm going to be measuring the mass of the cookies as time goes on. So before you draw, I want to talk about the Chips Ahoy. So if you were to describe this Chips Ahoy, you would probably say that it is round, or it is circular, right? But if you asked geologists to describe this as if it were a sediment, they would describe it as flat and not necessarily as round. Because round would more describe something that is spherical, smooth on all sides. Now, yes, this is round in this perspective, but from this perspective, it is flat. So it is more flat than it is round. So keep that in mind. So for now, I'm going to have you draw the Chips Ahoy where it says 0 shakes and the wafer where it says 0 shakes. I would draw the front version and I would draw the side version for both. And I am going to get the mass. So just so you know, you can pause this video to do these drawings at any point and then continue them. So, the mass of the Chips Ahoy, 10.8 grams. 10.8 grams for the mass of the Chips Ahoy, 0 shakes. The mass of the wafer cookie is also 10.8 grams. Wow, okay. So you should have the drawing here of the Chips Ahoy, front and side, the drawing here of the wafer cookie, front and side, and then the mass of the Chips Ahoy which is 10.8, and the mass of the wafer cookie, which was also 10.8. All right, so now I am going to shake these for about 5 seconds. So now I've physically weathered these cookies and abraded the cookies, so we're left with something that looks like this. I'm going to take out the big pieces, the big chunks, and separate the wafer from the Chips Ahoy. There we go. And then I'm going to take this dust that's left in the bottom. I'm just going to toss it out. So what I want you to do now is, in the space for after 5 seconds, let's draw what the Chips Ahoy look like now and what the wafer cookie looks like. So I'll set it up so you can try to see these. So you don't have to draw them perfectly, but you may want to pause the screen so you can draw these. So you don't have to get the actual like perfect shape, but very close. And notice that the edges of the wafer are starting to become a bit more rounded than they are before. So draw that, and you can pause it. All right, so let me get the mass of the Chips Ahoy. I'm going to take all the pieces and measure the mass of it. Remember, I threw away some of the crumbs and I kept the big pieces. So the Chips Ahoy is now 10.6 grams. 10.6 grams of the Chips Ahoy is remaining. And 10.1 grams of the wafer is remaining. So 10.6 for the Chips Ahoy, 10.1 for the wafer. I think that's right. I think that's what it was. I may have to go back and just make sure. All right, so a little more violent shaking that time. Wow, really broke these cookies apart. Wait till you see them. So the Chips Ahoy, the reason why I was bringing up the fact that the Chips Ahoy was more flat than it is circular is because, rounded, more flat than it is rounded, is because as of now we can start to see that the Chips Ahoy pieces are becoming rounded. They're not quite flat like they were before. This one's still kind of flat, but you can see the edges that broke before are now starting to round, and the wafer is really starting to become round as well. So let's draw the Chips Ahoys now and the wafer cookies. Pause it. Okay. So we'll get the mass of the Chips Ahoy. The mass of the remaining Chips Ahoy after dumping the crumbs is 8.8 grams for the Chips Ahoy. 8.8 grams for the Chips Ahoy. And the wafer, or as my mom would say, the wafer is 7.5 grams. So we're going to do one final shake. I'm going to do a violent one. Okay. Oh yeah, we really did some damage here. So I'm going to, there's almost no wafer left. I'm going to separate out those chocolate chip cookie pieces, and we're only left with 2 wafer pieces. You can see the rest has really become crumbs. So that is crumbs, if you could see in there. It's got a lot of crumbs, a lot of wafer crumbs. That wafer abrades really easily. That wafer abrades really easily. So these are our pieces left. Let's draw them. Only 2 pieces remain of this, and they are really rounded. This even got really rounded. Even those flat sides are now starting to become round. So the cookies got smaller. They have less mass, and they've become very rounded. The remaining mass of Chips Ahoy is a total of 7.1 grams. Chips Ahoy is 7.1 grams. And the wafer is only 2.2 grams remaining. 2.2 grams remaining for the wafer. Okay? So I'm gonna toss these out. We never eat lab supplies. And that is going to be the entire lab right there. So that's the entire first half of the lab. And now we've got to make questions. Now, since the mass for both cookies started at 10.8 grams, I would do times in seconds on this x-axis. And on the y-axis, I would do grams. and I'd go 2 grams, 4 grams, 6, 8, 10, 12, 14, 16, 18. So going by twos. And then along the bottom here for time, I would do every 2 or 3 boxes is like 5 seconds, another 2 boxes, 10 seconds, another 2 boxes, 15 seconds. And then you're going to make a line for the mass of the Chips Ahoy, and then a separate line for the mass of the wafer. And then after that, based on everything that we learned and all the Nearpods that you've done, you'll be able to answer all these questions. Okay? Cool.